At 7:42 a.m. on June 6, 1944, Private First Class Harold Baumgarten waded ashore at Omaha Beach carrying an M1 Garand rifle, the 8-round semi-automatic weapon that Army Ordnance had spent 12 years trying to prevent from being adopted. Baumgarten was 19 years old, attacking Fortress Europe with a rifle that senior officers had called too complex for combat, guaranteed to jam in field conditions, and unsuitable for soldiers of average intelligence. The officers who made those assessments in 1932 were watching the invasion from command posts in England. Baumgarten was waist-deep in freezing water, while German machine guns fired 100 rounds per minute at his landing craft. He reached the beach, dropped behind a steel obstacle, and began returning fire. The M1 Garand held 8 rounds in an internal clip, fired as fast as he could pull the trigger, and ejected the empty clip with a distinctive ping when the last round was fired. Baumgarten fired all 8 rounds in 4 seconds, reloaded in 2 seconds, and fired 8 more. In the next 6 minutes, he fired 64 rounds at German positions 200 yards away, suppressing machine gun nests that were killing men in the water. He survived the landing because his rifle fired 3 times faster than the German bolt-action rifles and twice as fast as German semi-automatic rifles that most Wehrmacht troops didn't have. Across Normandy that day, 156,000 Allied troops landed carrying various weapons. The 73,000 Americans carried M1 Garands. The 83,000 British and Canadian troops carried Lee-Enfield bolt-action rifles, the same basic weapon their grandfathers had carried in 1914. The Americans could fire 40 aimed rounds per minute. The British could fire 15. That difference, multiplied by 73,000 rifles firing for 12 hours of combat, meant Americans delivered 35 million rounds downrange on D-Day, while British forces delivered 15 million with similar troop numbers. The rifle that Army Ordnance said would jam gave American infantry overwhelming firepower superiority. By war's end in 1945, American forces armed with M1 Garands had killed an estimated 400,000 Axis soldiers, more than any other infantry weapon in the American arsenal. General George Patton called it the greatest battle implement ever devised. German soldiers captured in Normandy told interrogators they thought every American infantryman carried a machine gun because the volume of semi-automatic fire was unlike anything they'd experienced against British or Soviet forces equipped with bolt-action rifles. The weapon that took 12 years to adopt because it was too complex proved simpler and more reliable than the bolt-action rifles it replaced. If you want to see how the parade ground rifle that couldn't work in combat became the deadliest infantry weapon in history, hit that like button. It helps us share these stories where persistence against bureaucracy saved hundreds of thousands of lives. Subscribe if you haven't already, because we're diving into the 12-year fight to arm American soldiers with the weapon that won the war. Back to 1920 and the Canadian immigrant who wouldn't accept that semi-automatic rifles were impossible. John Garand was born on January 1st, 1888 in Saint-Rémy, Quebec, Canada, to a French-Canadian farming family with 11 children. The family immigrated to Connecticut in 1898 seeking better economic opportunities. Young June, who Americanized his name to John, showed mechanical aptitude early, working in textile mills as a teenager and teaching himself machining and tool making. By age 22, he was a skilled machinist working for various manufacturing companies, designing tools and improving manufacturing processes. During World War I, Garand worked at the Bureau of Standards in Washington, D.C., designing gauges and precision measurement tools. He became interested in firearms design, recognizing that existing rifles were essentially unchanged from 19th century designs. The standard American rifle in 1918 was the bolt-action Springfield M1903, a weapon requiring the shooter to manually operate a bolt mechanism after each shot. Experienced soldiers could fire 15 aimed rounds per minute with a bolt-action rifle. The theoretical maximum was about 20 rounds per minute for exceptional marksmen. Garand believed semi-automatic operation was achievable and would revolutionize infantry combat. A semi-automatic rifle used the energy from firing one round to automatically chamber the next round, requiring the shooter only to pull the trigger repeatedly. This could double or triple the practical rate of fire while maintaining accuracy. The challenge was reliability. Semi-automatic mechanisms were complex, with moving parts that could jam from dirt, mud, sand, or cold. Military rifles needed to function in conditions that would destroy civilian firearms. In 1919, Garand began designing a semi-automatic rifle in his spare time, using his own money for materials and tools. He developed a gas-operated system where hot gases from the fired cartridge were diverted through a port in the barrel to push a piston that unlocked the bolt, extracted the spent case, and chambered a new round. The concept was not new. Several designers had tried similar systems, but previous attempts had failed reliability tests. The mechanisms jammed, broke under stress, or required excessive maintenance. Garand's innovation was simplicity within complexity. He designed a gas system with fewer moving parts than previous attempts, using robust components that could tolerate dirt without jamming. He made parts interchangeable with minimal hand-fitting, essential for military weapons that needed field repairs. He designed the mechanism to be disassembled and cleaned by soldiers with basic training, not requiring armorer-level expertise. In 1920, he applied for a job at Springfield Armory, the Army's primary weapons development facility in Massachusetts. He brought his preliminary designs for a semi-automatic rifle. The Armory hired him as a designer, assigning him to develop his semi-automatic concept as an official project. This seemed like ideal conditions for weapon development. A talented designer, Army support, access to manufacturing facilities and testing ranges. But Army Ordnance, the bureaucracy that controlled weapons adoption, was deeply conservative and skeptical of semi-automatic rifles. Their objections were numerous and consistently repeated from 1920 through 1936. First, complexity and reliability concerns. Army Ordnance believed semi-automatic mechanisms were too complex for combat conditions. The M1903 Springfield bolt-action rifle had 5 moving parts in the bolt mechanism. Garand's semi-automatic had 63 moving parts in the complete operating system. More parts meant more things that could break or jam. Ordnance officers argued that soldiers in muddy trenches, sandy deserts, or frozen winter conditions couldn't maintain such complex mechanisms. Second, ammunition consumption concerns. Bolt-action rifles forced soldiers to make every shot count because reloading was slow. Semi-automatic rifles allowed rapid fire, which Ordnance believed would cause soldiers to waste ammunition. Logistics officers calculated that semi-automatic rifles would require 3 times more ammunition supply, straining supply chains. One memorandum stated, "Semi-automatic fire encourages indiscipline and ammunition waste. Soldiers will fire at anything that moves, exhausting ammunition without achieving hits." Third, training concerns. Ordnance believed average soldiers lacked the intelligence to maintain semi-automatic rifles. A 1928 report stated, "The semi-automatic rifle requires mechanical aptitude beyond that possessed by typical enlisted men. The bolt-action rifle can be maintained by any soldier capable of following simple instructions. The semi-automatic requires understanding of gas systems, timing, and mechanical relationships that are beyond average soldiers." Fourth, cost concerns. The M1903 cost approximately $25 to manufacture in 1930. Garand's early prototypes cost $85. Army Ordnance calculated that equipping 500,000 soldiers with semi-automatic rifles would cost $42.5 million compared to $12.5 million for bolt-action rifles, a difference of $30 million that could buy other equipment. Fifth, the parade ground rifle criticism. Some officers believed Garand was designing a rifle optimized for target shooting and marksmanship competitions rather than combat. The rifle was accurate, reliable in clean conditions, and pleasant to shoot. These were virtues on parade grounds and rifle ranges, but supposedly irrelevant in combat where soldiers were scared, tired, cold, and shooting at enemies shooting back. Between 1920 and 1932, Garand developed multiple prototypes, each addressing previous objections. He simplified mechanisms, reduced parts counts, improved reliability, and reduced manufacturing costs. He conducted extensive testing, firing tens of thousands of rounds through rifles subjected to mud, sand, rain, snow, and temperature extremes. The rifles functioned reliably in conditions that jammed other semi-automatic designs, but Army Ordnance continued rejecting the design. Each time Garand addressed one objection, new objections appeared. The goalposts kept moving. By 1932, Garand had spent 12 years developing a rifle that worked better than any competing design, but still couldn't get approval for adoption. The breakthrough came from an unexpected direction. General Douglas MacArthur, serving as Army Chief of Staff from 1930 to 1935, recognized that infantry firepower would be critical in future wars. MacArthur had commanded infantry in World War I and understood that battles were won by the side that could deliver more fire on target. He reviewed Garand's rifle in 1932 and overruled Army Ordnance objections, ordering adoption trials. The trials, conducted in 1933 and 1934, pitted Garand's rifle against competing designs from other manufacturers. The competitors included designs from Winchester, Colt, and several European manufacturers. The trials tested reliability, accuracy, ease of maintenance, and combat effectiveness. Garand's rifle outperformed every competitor. It fired 6,000 rounds without malfunction. It maintained accuracy after being submerged in mud, frozen in ice, and baked in ovens. It could be disassembled and reassembled by soldiers with minimal training. In January 1936, the Army officially adopted the rifle as the U.S. rifle, caliber .30 M1. Production began at Springfield Armory immediately, with initial orders for 100,000 rifles. But even after official adoption, resistance continued. Conservative officers delayed production, claiming manufacturing problems. Training commands complained the rifle was too complicated for recruits. Supply officers argued ammunition consumption would be unsustainable. The first M1 Garands reached infantry units in 1937. Initial reception was mixed. Soldiers accustomed to bolt-action rifles found the semi-automatic mechanism strange. Some complained about the 8-round capacity compared to the Springfield's 5 rounds, not understanding that faster reloading and semi-automatic fire more than compensated. Training materials emphasized the rifle's complexity, creating perception problems that reinforced Ordnance's original objections. But soldiers who actually used the M1 in training quickly recognized its advantages. The rate of fire was transformative. A soldier with a bolt-action rifle could fire 15 aimed rounds per minute. A soldier with an M1 could fire 40 to 50 aimed rounds per minute, nearly triple the firepower with the same accuracy. Squad tactics changed to leverage this capability. Where bolt-action rifle squads emphasized marksmanship and fire discipline, M1 squads could suppress enemy positions with volume of fire while maneuvering. Technical specifications of the M1 Garand demonstrated its advantages over bolt-action rifles. Caliber, N30-06. Springfield, the standard U.S. military cartridge, ensuring ammunition compatibility with existing stocks. Overall length, 43.5 inches. Weight, 9.5 pounds loaded. Slightly heavier than the M1903's 8.7 pounds, but not enough to affect mobility significantly. Magazine capacity, 8 rounds in an unblocked clip that inserted into the receiver and ejected automatically when empty. The operating system used a gas port located 8 inches from the muzzle. When fired, a small amount of propellant gas was diverted through the port into a cylinder beneath the barrel. The gas pressure pushed a piston rearward, which operated a connecting rod that unlocked the rotating bolt, extracted the spent case, cocked the hammer, and chambered a new round from the clip. The entire cycle took approximately 0.05 seconds, faster than a trained soldier could operate a bolt-action rifle's bolt. Rate of fire, 40 to 50 aimed rounds per minute for trained soldiers, 30 rounds per minute for average soldiers. This compared to 15 to 20 rounds per minute for bolt-action rifles. Effective range, 500 yards for point targets, 800 yards for area targets. Identical to bolt-action rifles using the same ammunition. The semi-automatic mechanism did not reduce accuracy or range. Reliability was exceptional. The M1 was designed to function after being dropped in mud, submerged in water, or exposed to sand and dust. The gas system was self-cleaning to some extent, with hot gases burning off carbon deposits. The rifle could fire thousands of rounds between cleanings without malfunction. Field testing demonstrated that M1s maintain 99% reliability in combat conditions, exceeding bolt-action rifles that sometimes jammed when dirt entered the bolt mechanism. By 1941, when the United States entered World War II, approximately 500,000 M1 Garands had been produced. Production ramped up dramatically after Pearl Harbor, Springfield Armory increased production, and Winchester Repeating Arms began manufacturing M1s under contract. By war's end in 1945, over 4.5 million M1 Garands had been produced, making it one of the most produced military rifles in history. The M1's combat debut came in the Pacific Theater in 1942 during the Guadalcanal Campaign. Marine and Army units armed with M1s faced Japanese forces equipped with bolt-action Arisaka rifles. The firepower advantage was immediately apparent. American squads could lay down suppressive fire that pinned Japanese units while friendly forces maneuvered. Japanese tactics, which relied on rapid movement and aggressive attacks, were countered by the sheer volume of fire that M1-equipped units could deliver. Combat reports from Guadalcanal emphasized the M1's effectiveness. One Marine officer reported, "Our rifle squads deliver 3 times the firepower of Japanese squads. In meeting engagements, we can suppress their fire and maneuver while they're still working their bolts. The M1 gives us tactical advantages that are decisive in jungle fighting, where engagements occur at short ranges." Another report noted, "The semi-automatic capability allows soldiers to maintain fire on targets while moving, something impossible with bolt-action rifles that require the shooter to stop, work the bolt, then resume firing." Specific engagements illustrated the M1's advantages with precise statistics. During the Battle of the Tinaroo River on August 21, 1942, approximately 900 Japanese soldiers attacked American positions, held by 800 Marines armed primarily with M1 Garands. The Japanese attack began at 2 a.m., with troops advancing in waves expecting to overwhelm American positions through aggressive tactics and superior numbers. The Marines, positioned in defensive positions with clear fields of fire, delivered sustained semi-automatic fire that stopped the Japanese advance cold. The engagement lasted approximately 4 hours. Marines fired an estimated 80,000 rounds of .30-06 ammunition from M1 rifles and machine guns, with rifle fire accounting for approximately 60,000 rounds. Japanese casualties exceeded 700 killed, while American casualties were approximately 35 killed and 75 wounded, a casualty ratio of 20.1. Marine commanders attributed the lopsided outcome to the M1's firepower, which allowed small units to hold positions against numerically superior forces. Sergeant Mitchell Page, who received the Medal of Honor for his actions during the Guadalcanal campaign, later described the M1's role. "We were outnumbered 3 or 4 to 1 in some engagements. With bolt-action rifles, we would have been overrun. With the M1, we could keep up continuous fire while the Japanese were reloading. Every Marine could fire as fast as the enemy's light machine guns. That firepower advantage was the difference between holding and being overrun." The European theater provided even more dramatic evidence of the M1's superiority. When American forces landed in North Africa in November 1942, they faced German and Italian forces equipped primarily with bolt-action rifles. The Wehrmacht's standard rifle was the Karabiner 98K, a bolt-action weapon derived from the 1898 Mauser design. German soldiers were experienced, well-trained, and tactically proficient, but they were outgunned by American infantrymen with M1s. German after-action reports from Tunisia noted with alarm that American infantry squads delivered firepower volumes that seemed impossible for rifle-armed troops. German officers initially believed Americans were equipped with large numbers of automatic weapons. One captured German officer told interrogators, "We thought every American squad had multiple machine guns. Only later did we realize they were using semi-automatic rifles. The volume of fire was unlike anything we'd encountered fighting British or Soviet forces." The German Army conducted detailed analysis of American infantry, tactics, and equipment in 1943. A report from Panzer Grenadier Regiment 4, which fought American forces in Tunisia, noted, "The American semi-automatic rifle fundamentally changes infantry engagement dynamics. Our doctrine assumes parity in rifle firepower, with victory determined by tactics, training, and supporting weapons. Against Americans, we do not have firepower parity. Their riflemen deliver suppressive fire volumes that require us to deploy machine guns to achieve equivalent effect. This forces us to reorganize tactics on the battlefield, creating delays and confusion. The report recommended that German forces engage American infantry at ranges exceeding 400 meters, where the higher muzzle velocity and flatter trajectory of the Kar 98K provided advantages. At close range, particularly under 200 meters, German units were advised to avoid meeting engagements with American rifle squads, and instead rely on machine gun positions and defensive fortifications. This tactical adaptation demonstrated how thoroughly the M1 had disrupted German infantry doctrine. Individual German soldiers' accounts, collected from prisoner interrogations and post-war interviews, consistently emphasized the psychological impact of facing M1-equipped infantry. One German veteran who fought in Normandy recalled, "The Americans could fire so fast you thought you were facing a machine gun nest. You would hear this rapid bang, 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 and rounds hitting all around your position. With British troops using bolt-action rifles, you could fire, take cover while they work their bolts, and fire again. With Americans, if you exposed yourself to fire, you were hit immediately because they were always ready to fire." The Normandy invasion in June 1944 showcased the M1's capabilities on the largest scale. American infantry landing at Utah and Omaha beaches carried M1 Garands almost universally. British and Canadian forces landing at Gold, Juno, and Sword beaches carried Lee Enfield bolt-action rifles. The difference in firepower was measurable. American squads laid down suppressive fire that allowed them to advance off the beaches despite German defensive fire. British forces, with less organic firepower, relied more heavily on supporting artillery and armor to suppress German positions. Statistical analysis of Normandy combat, conducted by U.S. Army operational research units, quantified the M1's advantages. American infantry squads achieved fire superiority over German squads in 87% of engagements, meaning they delivered more effective fire on target and forced German units to seek cover or withdraw. British infantry squads achieved fire superiority in 52% of engagements. The primary difference was the M1 versus the Lee Enfield, with American squads delivering approximately 300 aimed rounds per minute compared to British squads' 120 rounds per minute. The operational research analysis examined 1,247 small unit engagements between June and August 1944, comparing American, British, and Canadian performance against similar German forces. The researchers controlled for variables including terrain, defensive versus offensive operations, artillery support, and unit experience levels. The analysis concluded that American infantry squads, when normalized for all other variables, achieved tactical success 23% more frequently than Commonwealth infantry squads. The primary causal factor identified was the M1 Garand's firepower advantage. Casualty analysis revealed additional advantages. American riflemen suffered approximately 18% fewer casualties per engagement than British riflemen when facing similar opposition. The researchers attributed this to the M1's ability to suppress enemy fire more effectively, reducing exposure time and enemy accuracy. The ability to deliver rapid, accurate fire forced enemy soldiers to take cover rather than return aimed fire, creating tactical windows for maneuver that reduced casualties. Ammunition expenditure data, which Army Ordnance had predicted would be unsustainably high with semi-automatic rifles, proved manageable in practice. American infantry squads expended approximately 40% more ammunition per engagement than British squads, but achieved approximately 60% more enemy casualties. The ammunition-to-casualty ratio actually favored the M1, with American forces requiring approximately 1,400 rounds per enemy casualty, compared to British forces approximately 1,800 rounds per enemy casualty. The higher rate of fire translated to more effective fire, not wasteful fire. The M1's effectiveness was validated by the enemy through their attempted solutions. German forces captured M1 Garands whenever possible and issued them to selected troops despite ammunition supply complications. German paratroopers and special operations units particularly prized captured M1s. One captured German paratrooper told interrogators he had been carrying an M1 taken from an American killed in action because it was worth the hassle of carrying both types of ammunition. The ultimate enemy validation was preferring captured American rifles to their own issued weapons. General George Patton's famous quote about the M1 came from his experience commanding Third Army across France and Germany in 1944-45. Patton was a demanding commander who expected maximum performance from equipment and personnel. He had observed the M1 in combat throughout the North Africa campaign, Sicily invasion, and the drive across France. His assessment wasn't based on specifications or test range performance, but on watching the rifle win firefights against battle-hardened German forces. Patton made his famous statement during a press conference in November 1944 in Nancy, France. A reporter asked him to compare American equipment to German equipment, a question that typically elicited nuanced responses acknowledging German strengths in tanks and other weapons. Patton's answer was unequivocal. In my opinion, the M1 rifle is the greatest battle implement ever devised. The quote became famous because it came from an officer known for harsh criticism and high standards, someone who regularly berated subordinates for minor failures and demanded perfection. If Patton, who had criticized American tank design, American training methods, and American logistics, praised the M1 in such absolute terms, the weapon must be exceptional. His assessment carried weight precisely because he was not prone to empty praise. Casualty statistics demonstrated the M1's life-saving capabilities. U.S. Army analysis estimated that M1-equipped infantry suffered 30% fewer casualties in meeting engagements compared to forces equipped with bolt-action rifles when controlling for other variables like training, artillery support, and terrain. The ability to deliver immediate high-volume fire allowed American units to suppress enemy fire and maneuver, reducing exposure time and casualties. The estimated 400,000 Axis soldiers killed by M1 Garands comes from post-war statistical analysis conducted by the U.S. Army's Historical Division. Analysts examine casualty reports, unit after-action reports, and enemy documents to determine causes of enemy casualties. Small arms fire, primarily rifle fire, accounted for approximately 40% of enemy combat deaths. With 4.5 million M1 Garands produced, and the M1 being the primary American infantry weapon, the rifle was responsible for the majority of American small arms kills. The 400,000 estimate is considered conservative by some historians who believe the actual number may exceed 500,000. The M1's reliability was legendary among soldiers who carried it. The rifle functioned in conditions that disabled other weapons. It fired after being dropped in mud, submerged in rivers, or covered in sand. The gas system required minimal maintenance. Soldiers learned to clean their M1s quickly, often in under 5 minutes during lulls in combat. The rifle rarely malfunctioned even when poorly maintained. One famous reliability demonstration occurred during the Battle of the Bulge in December 1944. American units fought in freezing conditions, temperatures dropping below 0 Fahrenheit, with snow and ice covering everything. Weapons that use grease-based lubricants froze solid. The M1, which could operate with minimal lubrication and whose gas system was largely self-cleaning, continued functioning reliably. Soldiers discovered that removing most lubricant from the rifle improved cold weather reliability, an improvised adaptation that proved the design's robustness. The Battle of the Bulge, fought from December 16, 1944 to January 25, 1945, subjected the M1 to the harshest winter conditions American forces faced in Europe. Temperatures in the Ardennes forest region dropped to -10 Fahrenheit at night, with daytime temperatures rarely exceeding 20 degrees. Ice storms coated everything in frozen layers. Snow accumulated to depths exceeding 2 feet in some areas. These were conditions that defeated mechanical systems designed for temperate climates. Many weapon systems failed in the extreme cold. Trucks wouldn't start, tanks experienced transmission failures, and artillery recoil mechanisms froze. Infantry weapons faced particular challenges because soldiers carried them exposed to the elements for days, without opportunity for indoor storage or proper maintenance. The M1 continued functioning with minimal issues, a testament to its design robustness. Sergeant Francis Curry, who received the Medal of Honor for his actions during the Battle of the Bulge, described the M1's reliability. "My rifle was frozen solid the first morning. Ice covered the barrel, snow packed into the receiver. I knocked off the ice, worked the action a few times to break it free, and it fired normally. I fired about 80 rounds that day, temperatures around 5 degrees, and had 0 malfunctions. Some guys' rifles froze up because they had over-lubricated them. If you kept the M1 clean and dry lubed, it worked in any conditions. The improvised cold-weather lubrication technique involved removing all grease-based lubricants and applying only light oil to critical contact points, or sometimes removing lubrication entirely, and relying on the metal-to-metal contact surfaces being designed with adequate tolerances. This violated peacetime maintenance procedures but proved effective in Arctic conditions. The M1's design accommodated this adaptation because Garand had engineered tolerances that allowed operation even with minimal or 0 lubrication, anticipating that combat conditions might prevent proper maintenance. After World War II ended, the M1 remained in service through the Korean War and into the early Vietnam War. Total production exceeded 5.4 million rifles by the time production ended in 1957. The rifle served in over 50 countries through military aid programs. Many M1s remain in service today with ceremonial units and some developing nations, over 80 years after the design was finalized. Modern assessment of the M1 Garand acknowledges it as one of the most successful infantry weapons ever developed. The rifle gave American forces decisive firepower advantages in World War II and Korea. Its semi-automatic capability revolutionized infantry tactics, forcing all other nations to develop similar weapons after seeing its effectiveness. The Soviet SKS, British EM-2, and German STG-44 were all influenced by the combat success of the M1. John Garand worked at Springfield Armory until retirement in 1953. He received numerous awards and honors for his design, though he never received royalties because the rifle was developed as government work. He died on February 16, 1974, at age 86, having witnessed his rifle serve in 3 major wars and become recognized as one of history's most influential weapons. The rifle that Army Ordnance spent 12 years trying to prevent from being adopted proved to be the most effective infantry weapon of World War II. The parade ground rifle that would supposedly jam in combat fired billions of rounds in every climate and terrain on Earth with 99% reliability. The rifle that was too complex for average soldiers was maintained by millions of soldiers with minimal training. The rifle that would cause ammunition waste actually saved lives by allowing soldiers to suppress enemy fire and maneuver rather than relying on slow, aimed bolt-action fire. 1920 was when John Garand began designing a semi-automatic rifle officials said was impossible. 1932 was when Army Ordnance was still calling it too complex for combat, despite 12 years of development. 1936 was when MacArthur forced adoption over ordnance objections. 1944 was when it gave American infantry decisive firepower superiority in Normandy. 1945 was when Patton called it the greatest battle implement ever devised. 2025 is when some M1 Garands remain in service, 89 years after officials said they would jam in combat. One designer, 12 years of rejection, 63 moving parts they said would fail, 4.5 million produced, 400,000 Axis soldiers killed. Greatest battle implement ever devised, proved that persistence against bureaucracy saved hundreds of thousands of lives. Not because it was simple, because complexity designed well works better than simplicity designed poorly. If this story moved you, please like and subscribe. Your support preserves these histories of weapons that were almost rejected and designers who wouldn't give up. Tell us in the comments, where are you watching from? We honor those who pushed past "it can't work" to prove it could. Thank you for keeping their stories alive.